Let me try to explain to you how the sampling distribution works using an applet from Dr. West, who has some fantastic applets out there. So here we have our original population distribution. Notice I'm going to start with a nice bell curve. We'll talk later about what happens if it's not a bell curve. I'm going to start by only sampling 2 people. Oh look, here's the 2 people that I sampled. Here's the average that they got. Down here it's playing with the medium. Just ignore that for a second. Okay, if I did it again, would I get these same 2 people? The answer is no, there's no way. You'd get a different 2 people. Look, I got these 2 people, and I got a mean right there. Notice both my means are very close to the true mean here. If I do it again, this time my mean was a little further away. Why? Well, that's just bad luck. Sometimes that happens. Let's do it again. Whoa, way out there. Now, when I say way out there, for a person, that wouldn't be so strange. But for an average, I would have expected the average to be a little closer to the yellow arrow where it's supposed to be. Let's try it again, and again, and again. Notice most of the time, my average lands right where it's supposed to be. Sometimes, the average lands a little further away. That guy actually is still the furthest away that we've gotten so far. This is going to get really boring really quick, sitting here watching me click this. So let me click it 100 times over. Can you see a shape is starting to form here of what happens to the average? And let's try it 1,000 times. Oh, look. So most of the time, our average lands in here, sometimes out there. Now, are these 2 pictures exactly the same? And the answer is no. This one's actually a little skinnier. It's hard to see on the camera, but it's true. Now, is this picture the same as that one? No way. It looks like 2 dots, and this looks like a bell curve. Let's reset, and I'm going to increase the sample size to 10 now. So there's the 10 people I got in my sample. There was the average. How close was it to the true average? Really, really close. Well, was that luck? Let's do it again. This time my average wasn't as close, right? It was a little further out. Let's do it again and again. And we can play the same game we just played before, except you don't want to sit here and watch me actually do this over and over. So I'm going to do it 1,000 times. Wow, notice what's happened to our sample here. It is definitely skinnier. In other words, as you sample more and more people, your average should be closer and closer to the true average. That makes sense. If what I said doesn't make sense to you, that's a bad sign. Maybe you should come talk to me. Let's get this figured out. Okay, let's reset it. And let's reset it. I'm going to go back to only doing 1 click at a time. This time I'm going to sample 1,000 people. Notice something. This sample distribution is starting to look a lot like the original distribution, because if you sample enough people, it'll look like it. Watch what happens if I do it again. Every one of these is starting to show that bell curve shape, because with 1,000 people, we have enough to see it. Look what's happening to my averages, though. Way, way skinny. So here's what we've learned. If I start with a bell curve, then my sampling distribution is going to be still bell curve-ish, but skinnier. Let's see what happens if it's a skewed distribution. All right, I'm going to go back to sampling only 2 people. Wow, both those people were really high. I'll bet that was luck. I'll bet it won't happen again. This time my average was lower. This time my average was way low. Okay, so let's click this 1,000 times. Notice the shape. Would you say that this is shaped normally? And most people are going to say, no, it doesn't look normally distributed. It looks skewed. Okay, let's reset it. This time I'm going to sample 30 people. There's my 30 people. There's my average. Do it again. There's my 30 people. There's my average. Let's do it again and again and again and again. Look at that. It skinnied up, but not only did it skinny up, it bell curved out. I don't know if that's actually a verb. I kind of made that word up. But it became more normal and bell curved out. I'm going to make this even more extreme. I'm gonna make this. You know what I'm going to do? I'm going to make this look totally non-normal to start with. Okay? So I'm going to do samples of 2. Look, both those were high. Both high, both high, both low. 1 high, 1 low. As I click these, what's happening? Well, sometimes both my people are in the high group. Sometimes they're both in the low group, and sometimes one's high and one's low and it lands in the middle. So if I click this 1,000 times, that's what my picture is. Does my sampling distribution look normal? Answer, no. It looks like a weird three-pronged something. Well, instead of sampling 2 people, let's sample 3. Now I have 4 prongs, right? Because all 3 could be high, which is why we have a bump here. All 3 could be low, which is why we have a bump here. You could have 2 low and 1 high. That's this guy. You could have 2 high and 1 low. That's this guy. Still doesn't look normal. Let's increase it to 5. Well, that just means we have 6 bumps. Does it look normally distributed? No way. Looks all weird and bumpy. What if there's 10? Well, what's interesting is there are 11 bumps, but they've started to meld into each other. It's starting to look more like a normal distribution. If I do 30, yeah, this looks like a normal distribution, nice and pretty. The median is having a hard time, okay? Median really kind of looks ugly. So we don't do a lot with the median in this class, like almost none from here on out. But the mean, we can do something because we can say something about the mean. Here's what we can say. If you start with a normal distribution, the mean is going to be normal. If you don't start with a normal distribution, but your sample size is really large, then your sampling distribution is still going to look normal.